सर हमारा मिड कब होगा?
Lecture of MATH120. Mid, I'll send you email today, hopefully. In the previous lecture, we were discussing some of the properties of vectors. Vectors means they are elements of n space. Okay? N space. Space normally n जो है ना वो छोटा लिखते हैं. So you follow this. N space or Euclidean space. There are two basically major categories of properties. Properties आप कह सकते हैं कि properties under addition. We use mainly the addition of vectors and the properties with respect to you can also say this with respect to scalar multiplication. Number one, properties with respect to addition. We have discussed these properties in the previous lecture. What was these properties? These properties include commutative law, means for any two vectors x, y belongs to Rn. X plus y is equal to y plus x. This was commutative property with respect to addition. B was associative law for any x, y, z belongs to Rn. The property was x plus y plus z bar x plus y plus z and x plus y plus z. This was what? This was associative law. Another property which we defined, it was identity element for all x belongs to Rn. There exists E belongs to Rn such that x plus E is equal to E plus x is equal to x. So this was the property which was identity element, and D was inverse element for all x belongs to Rn. There exists a negative x belongs to Rn. Negative x is basically the additive inverse of x, such that x plus minus x is equal to negative x plus x is equal to identity. These were the properties we discussed in the previous lecture. These are all the properties of vectors with respect to addition. Because in all these properties, addition of two vectors or three vectors involved. Yes?
Sir, your voice is really breaking up. आपकी आवाज सही clear नहीं आ रही है.
Oh, यार क्या करें इसका फिर? I'll try to speak a bit louder, maybe. Can you listen me now properly?
It's better, sir. It's better.
Okay. So these were the properties we discussed with respect to addition. Now we are going to discuss some of the properties with respect to the scalar multiplication. I hope you know how to. Again, first of all, for Rn, we should be given how to add two vectors and how to do the scalar multiplication with a vector. Okay, these two operations should be defined. Operations, two operations. Okay, two basic operations, you can say. Basic operations on elements of Rn should be defined. Okay. After this, we can prove all these properties. Okay. And what are these two operations? Basic operations. These are two addition of factors. How to add means addition of any two factors. Okay. And number two, scalar multiplication. Scalar multiplication with a vector. These two basic operations should be defined after by using the definition of addition of two vectors and scalar multiplication of two vectors. We can prove all these properties for Rn. Okay. Now, for in order to write the properties of scalar multiplication, we need to know how the scalar multiplication is performed in this space Rn. मतलब एडिशन क्या कैसे हम डिफाइन करते थे? आई होप यू नो हमने डिफाइन की थी. इट वाज x1 x2 so on xn plus y1 y2 so on yn. तो ऐड कैसे करते हैं हम वेक्टर्स को? वी ऐड द कॉरस्पॉन्डिंग कंपोनेंट्स ऑफ वेक्टर्स. ठीक है, दिस इज हाउ द एडिशन इज डिफाइंड. ठीक है, एंड स्केलर मल्टीप्लिकेशन कैसे डिफाइन है? k times x, k times x1 x2 so on xn. It is, we multiply the scalar with each component, x1 kx2 so on kxn. So these two basic operations are defined in this way. Now using these definitions we have to prove all these properties. Okay. Now number two, the properties with respect to scalar multiplication. Okay, now we are going to write these properties. Okay, number one property is you can say it A. Let me write them in a proper order so that C times for all, you can say that for all C belongs to R and X comma y belongs to Rn. Okay. So in these properties we need at least one scalar and at least one vector. Okay, because we are going to write some property which involves scalar multiplication. So the property is C times x plus y is equal to C times x plus C times y. Okay. And this is called a kind of left distributive law. Okay. Or distributivity. इसका नाम लिखा हुआ है slides पे, you can read it. So we can prove this property by taking left hand side. By starting with the left hand side, we can arrive on the right hand side. Second property is for all C D belongs to R. Whenever I write C belongs to R and C D belongs to R, what does it mean? Obviously, they are scalars. They are not vectors. Okay. C D belongs to R and X belongs to Rn. The property is now C plus D times X is equal to C times X plus D times X. It's a kind of distributive property, but it's a different from usual distributive property because here we have two scalars and one vector. So it's basically when we write C times X, it means it's a scalar multiplication of a scalar with a vector. Okay. Similarly, all these things. You should imagine these products as a scalar multiplication, which is defined there. How to do scalar. Another property is जी.
वो पुराना बोर्ड वापस लाए क्या?
परवला. Yes.
नहीं सर, जो अभी आपने जो जिस पे करा रहे थे.
अच्छा.
सर ये जो आपने पार्ट ए और बी में जो आर के बाद लिखा है वो सिंबल की नोटेशन क्या है?
एंड यहाँ
आर के बाद जो है जी ये सर
एंड यार
एंड Sir, एक बात to confirm कर दें.
जी बेटा.
You said the last thing which we did in the last lecture, said you said that we will be starting this lecture with that thing because that remained unclear and like unexplained. So is that linked with this thing which we are doing, these laws?
In last lecture, which was unexplained or unclear.
So the last thing which we did in the last lecture, you said that we will starting again with that in the next lecture.
Okay. We'll discuss it. Okay, don't worry. So the next property is again another property which is for all C D belongs to R and X belongs to Rn. C times D up CDU is equal to C times D times X is equal to C D times X. Okay. And the last property is one for all X belongs to Rn. 1 dot X is equal to X. So the last is, you can say that it is multiplicative identity kind of thing. Okay. And this, you can take it that if we have a scalar, we multiply it with a vector. Then again, we have another scalar and we multiply this C with this whole dx. It is equivalent to first you multiply CD and then multiply with a vector. So these kind of properties are. So these are all properties with respect to scalar multiplication. We can prove them easily for any Euclidean set. For example, if we are given maybe R, Rn pe hi kar lete hain. If we are given Rn and we need to prove any one of these properties, I'll prove only one. Which one should I prove? Maybe this one or this one? B1. Okay. I'm going to prove the B1 and then you, I hope you can do the rest yourself. So for all C, we need two numbers, two scalars, which belongs to R and a vector from Rn. Okay. Now we need to prove C plus D times X bar is equal to CX plus DX. Okay, we have to prove it. Now we consider the left hand side. We consider C plus D times X. Okay. Now we need X, the definition of X. Where this X, where does this X come from? It comes from Rn. Okay. So the form of X should be, we should know it. What would be the form of X? X should be X1, X2, so on, Xn. Okay. Now, this C plus D is a number, is a scalar, because sum of two scalars is a scalar. And how to perform this scalar multiplication? This is already defined here. How do we multiply a scalar with a vector? This is defined here. We'll use this definition. I can change this definition, in fact. Okay. If I say we don't multiply a scalar with a vector in this way, this is a standard scalar multiplication, but one can change it. The definition can be changed according to your practical application. Okay. Now, I say that this multiplication is x1 power k, x2 power k, and so on, xn power k. This is how I multiply a scalar with a vector. It's my choice. How do I define the scalar multiplication? Then we'll use scalar multiplication in this way. Okay, I can change it to some other definition depending on the practical application which you are working in. I say that the scalar multiplication is k x1. All other things are 0. Okay, this is the definition. Definitely effect पड़ेगा. All the properties जो है ना will prove all the properties by looking at this definition. So they might we maybe we may prove them that they are true. They might not be true according to this definition. Okay, it depends. No, the definition depends on a practical application. For example, जैसे कि वो मैंने एग्जांपल दी थी लाइट व्हेन लाइट इज कमिंग, ठीक है, उसमें सारी रेज हैं, ठीक है, व्हेन दैट लाइट पास थ्रू अ सर्टेन मीडियम, ठीक है, तो कुछ रेज पास कर जाती हैं, कुछ नहीं कर, ठीक है. इन दैट केस you can say that the light is coming from the sun, ठीक है, you pass that light from a certain medium, उसका एक कंपोनेंट जो है ना एक सर्टेन काइंड ऑफ रे जो है पास कर रही है, बाकी सारी रिफ्लेक्ट कर जाती है. Then in that case we can change the basic definition depending on the application. ठीक है.
Sir,
Similarly,
so the constant k, it can be the power as well as a multiple, as something to be multiplied with.
no, it depends. This definition of a scalar multiplication depends on your practical application. You are working in a certain problem. जैसे मैंने अभी कहा
Sir,
कि
then how can it be that if we multiply k with x1 and it becomes kx1, but if we multiply k with x2, it becomes 0? Why do we have zeros in the resultant vector?
No, it depends on the application. How do you define the definition of a scalar multiplication? Okay, let me think some. Did you listen my previous example which I gave you?
Yes, sir, about light coming from different sources.
Yeah, okay. When that light passed through some certain medium, the properties of light can be changed. Okay. Now, how the properties are changing experimentally, you can look at in a lab. Okay. Depending on that changing kind of properties, you can define the definition of a product, scalar product. Okay, scalar multiplication, sorry, not scalar product. I'll give you some more examples. I'll find some and then we'll discuss this in more detail. Okay. So it depends what definition I define. Similarly, I can change this addition of vectors as well. Okay. I can change this definition depending on my situation, practical problem. Okay. I say that when I add these two vectors, their components are basically multiplied. Okay. This is how I define it. For example, you have two signals coming from two different sources, two different satellites. Okay. And you have the frequency data of those two signals. Okay. When you receive those two signals at a certain receiver, okay, and you get a wave. Okay. उन दो वो जो previous signals हैं उनकी frequency different है, और जो third signal निकल रहा है after receiving उसकी frequency different हो सकती है. It depends कि उसकी frequency क्या है. The third signal might have a frequency as a sum of two frequencies of the previous two signals, and the third signal may have a frequency which is obtained by multiplying the frequency of two previous signals.
Sir, can you please repeat this point?
Okay. So it depends on the practical application you are working in. Then we define the addition of vectors. These vectors could be any multi-dimensional thing. Okay. So it depends on the application. How do you define these operations? We can change the definition of operation depending on your practical application. Okay. Any question? Someone asked me some question. No? Okay.
Sir, can we
Ji.
comment? Sir, can we pass a comment that a vector is a scalar form of a matrix? Oh, sorry, a matrix is a scalar form of a vector.
A matrix is a scalar form of a
Vector.
vector.
Because all these 3 points of the 3 directions, they are part of the matrix. But when we go into the vectors, we say that they are in the x, y, or z directions. But when we come in the matrix, we don't refer to
Matrices
those
are
points.
different things. Matrices are different things. Vectors are basically they're elements of Euclidean spaces. Okay. These are also matrices, but they are column matrices. The dimension of a matrix is different, but the dimension of this vector is different. So this is, I think, very different from the matrix.
Right, sir.
So now I hope you get it. Okay, we can change these definitions. These are standard definitions of vectors. Okay, these are called, which we have defined here earlier, x1 plus y1, so on xn plus yn, and then here kx1, so on kxn. These are standard definitions of scalar multiplication. Okay, when standard addition and scalar multiplication, we call it. Okay, standard addition and scalar multiplication. But these standard definitions can be modified according to the situation we are in. We are trying to handle. Yes, we were proving this problem. Now, according to that definition, I can write C plus D times x1, C plus D times x2, so on, C plus D times xn. Okay, this one. Now, individually, C, D, x1, they are real numbers. We can split them up. Okay, so individually, but as a combine, we cannot do it directly. Okay, so you have to give a reason here, because C, D, x1, so on, xn, they're all real numbers. And this property holds for the real numbers, simple real numbers. Then we can split them up, and then we can split up the two elements to get this right hand side. Okay, we can reach at this right hand side by splitting these two things. You can write them here. We can write it cx plus dx. Okay, and then sorry, x1 x1 with cx2 plus dx2, and so on, cxn plus dxn. And this can further be written as cx1, cx2, so on, cxn plus dx1, dx2, so on, dxn. And further, you can take c common, d common, and you can write finally cx plus d. So this, which is what? Which is the right hand side. Okay. Now, if I change the definition, which I had written here, this one. For example, if I write x1k, x2k, so on, xn k. K goes in the power of each component. Then, यहाँ पे क्या होगा? What will have this according to that definition? x1
C,
power
x1.
c plus d. ये होगा ना? x2 power c plus d, and so on. Now, can we split them up? Yes, we can split them up. ठीक है, यहाँ पे क्या आ जाएगा? x1c into x1d. ऐसे होगा ना? Now, can we split them up?
Sir, are you using exponential law in order to like make that like
Yes.
in the
Yes.
okay.
Yes. we can separate them x1 power c, x1 power d in product. Now, can we separate them in a sum? No. So we cannot prove this property. Obviously. No, गलत नहीं है. अगर ये सही है according to practical application, then in those kind of vectors, they do not satisfy this property. A simple thing.
Sir, but sir, there's just like logically speaking, if you have a vector of a unit vector of length 1 and you're like multiplying with a constant factor of 5, so the length has to be like 5 units. So how is it not possible that you?
We are not talking about the lengths. We are talking about the vectors. Okay, that is different thing.
Sir, how are we changing like the laws of scalar multiplication over here? Like, for instance, अब हम लोग ये consider करेंगे कि C plus D is being multiplied with vector x. So how does it go into its power?
In life, in practical life, certain things are not standard. ठीक है. मसलन आप बाहर रोड पे जाते हैं, सिग्नल जब रेड होता है तो स्टैंडर्ड चीज क्या है कि आपने खड़े होना है. ठीक है. जो स्टैंडर्ड नहीं है वो क्या है? आप गुजर जाएं. तो बहुत सारी चीजें ऐसी होती हैं लाइफ में या नहीं?
Sir, but mathematical laws have to be like to a point.
Yeah, mathematical laws are basically, they are made for basically a certain applications. They could be changed in different applications. अब जरूरी नहीं है कि 2 और 5 जो है हमेशा साथ ही हो. It can be different in some different situation.
सर हमें कैसे पता लगेगा कि किस सिचुएशन में से क्या डेफिनेशन होनी चाहिए?
यही तो, आपने साइंटिस्ट बन रहे हो ना, आपने ही तो जज करना है कि किस सिचुएशन में हमने क्या ऑपरेशन लगाना है. तो ही वाज आस्किंग हमें कैसे पता चलेगा कि हमने कैसे स्टैंडर्ड ऑपरेशन को चेंज करना है. सो दिस इज यू हु आर गोइंग टू डिसाइड कि मैंने इस सिचुएशन में क्या करना है. ठीक है. वी आर गिविंग यू, वी आर ट्राइंग टू शो यू मल्टीपल ऑप्शंस. ठीक है. So there are many non-standard laws in nature जो कि आपके स्टैंडर्ड ऑपरेशंस को फॉलो नहीं करते.
Sir, can you explain this but दोबारा जो एक्सपोनेंट वाली चीज है?
इसमें क्या एक्सप्लेन करूं? टेल मी, क्या आपको समझ नहीं आया?
Like उसके बाद वाली चीज समझ आ गई है कि x की पावर c plus d is equal to x1 power c times x1.
या अब हमने यहाँ से राइट हैंड साइड लानी है. ये वाली राइट हैंड साइड को अगर आप सॉल्व करें तो राइट हैंड साइड में पहला वेक्टर क्या आना चाहिए? x1 c. ठीक है. प्लस दूसरे में क्या आना चाहिए? पहले x1 पावर d. कैन वी राइट दिस वेक्टर इन दिस फॉर्म? So the left hand side is not equal to right hand side. So the property is not proved. You got it?
So sir, it doesn't stand true for all. So
yes. No, ये property, particular property जो है वो under that definition it cannot be proved. It might be कि दूसरी properties prove हो जाएं. We have to check them.
Sir, is this x1 is a vector? The thing which you have written at the rightmost box.
x1. Yeah.
Yes, sir. Yes, sir.
This x1.
Sir, no, sir. The one which you pointed at the first. Yes, sir.
Yeah.
x1.
This x1 is a real number. X vector is x is a vector, x bar, which belongs to Rn. But individually, x1, x2, x3, so on, xn, they are real numbers according to the definition of Rn.
So can it, is it so that x1 is a member of x, the vector x?
Yes, x1 is a member of element. You can say that one component of x.
Right.
A single individual components are basically real numbers in Rn.
Right, sir.
Okay. So we cannot split this into a sum. because in the right hand side we need this. So we cannot go from here to this basically right hand side. So we cannot prove it. I hope you get it. So
Yes, sir.
let's
It is clear now.
okay. We'll do many other examples of this kind. I hope कि आपको समझ आ जाएगी. ठीक है,
सर आप
next.
कुछ भी है प्रूफ्स पूछेंगे हमसे?
हाँ हाँ डेफिनेटली आपके तो अभी तो तो
Sir,
दिमाग घूम जाएगा ऐसी ऐसी
if
चीजें
you want
पूछूंगी
you
मैं.
to include word problems,
Not word
because
problems,
that's
but
the only way
I'll
we'll have to change definitions, right?
yes, but I'll give you definitions in this course because you are not yet fully trained to do these things. You need more advanced courses of linear algebra to be able to do these things. But still, you can. I think in a certain situation, I'll try to find some practical example in which you have to define the addition and scalar multiplication of things, and then you have to prove the certain properties. Okay, that will help you. Okay, then what was I going to do now? We'll do many more examples of these things. Now, what is a Euclidean vector space? Euclidean, I think, Euclidean vector space. It is basically Rn. Okay. Let we say that V is equal to Rn. V stands for vector space. Okay. Let V is equal to Rn, and operations of addition, operations of addition. Yeah, you भी कह सकते हैं operation of addition and scalar multiplication are defined by. पहला क्या है addition? Addition जो कि usually for all x y belongs to Rn. हम जैसे define करते हैं इसको. I hope you can do it. This plus this is equal to this. Okay. Scalar multiplication is defined in a similar fashion जो कि हमने पहले define किया हुआ. For all k belongs to R and x belongs to Rn. I hope you know what is the scalar multiplication. K times x is equal to this. These are standard. I can also say that let V is equal to Rn with the standard addition and scalar multiplication. Okay, I can say this. Let V is equal to Rn with standard addition and scalar multiplication. I can say this. If I say this, it obviously means that जो के the addition or scalar multiplication हमने standard way में define की थी, that is the operations. Now, if the elements of this set, along with these two operations, basic operations of addition and scalar multiplication, if the elements of Rn, let me go to the other board. If the elements of Rn, they satisfy if the elements या इनको vectors कहेंगे. If the vectors of Rn satisfy following 10 properties.
Sir, could you please move the camera a little higher?
Okay. Sorry. This one maybe. Okay. Is it fine now? 10 properties. The following 10 properties. We have listed them there. Okay. The first property is, you can say it, Closure law. Okay. What is the Closure law? For all x, y belongs to Rn, implies x plus y belongs to Rn. This is the first one.
सर सर आपने वो पिछले वाले बोर्ड पे सेकंड पॉइंट क्या लिखा था
सेकंड
लेफ्ट साइड पे
स्केलर
Second
मल्टीप्लिकेशन में या एडिशन में?
सर एडिशन के बाद
स्केलर मल्टीप्लिकेशन में सेकंड पॉइंट
जी
क्या
सर
लिखा था?
वही पूछ रहा हूँ
स्केलर मल्टीप्लिकेशन लिखा था यार.
ओके
ठीक है. Now, this is the first property. The second property is commutative law. Third property is associative law. Fourth property is identity element. Fifth property is inverse element. Okay. Second is associative law. जो कि अभी हमने associative law और property, you can say third property is identity element should exist, or identity element should belongs to that space Rn. Identity element, you can say that should belong to Rn. The next is inverses should exist. Inverse of each element should exist in Rn. Fifth property is क्या थी? Closure law. Commutative. अच्छा सॉरी, commutative. यहाँ पे commutative second पे आनी चाहिए. ठीक है, second पे commutative होनी चाहिए. ठीक है, commutative law. And this should be third one, this should be fourth, this should be fifth. You have to keep the order of these properties. Otherwise, you cannot prove them. Why? Because in order to prove the inverse element, you need identity element. जैसे मैंने previous lecture में आपको example दी थी. If there is no identity in some certain set, then you cannot check the inverses. So you have to keep the order. The fifth one is for all k belongs to R and x belongs to Rn, implies k times x belongs to Rn. This is kind of a clear law, but it is not exactly the clear law. Clear law with respect to the scalar multiplication, you can say it. The sixth property is, and the seventh, eighth, ninth, 10th, जो कि हमने अभी scalar multiplication के जो properties लिखी है ना, ठीक है? Those are the properties. For example, c times x plus y is equal to cx plus cy. Okay. The seventh is c plus d times x is equal to cx plus dy. Okay. And eighth one is c times dx is equal to cd times x.
Sir, when
And
we were
ninth,
doing
G.
So when we were doing this, like a plus b or whatever we were doing, like b or c probably into vector x, we said that it would be like x raised to power c product d raised to power d raised to power x. So what was that and why we are changing that over here?
Let me finish with this, then I'll come back to you. Okay, remind me this later on. What you were
Okay.
saying? हाँ, 5 के बाद ये 6 होगी, ठीक है? This one 6th, this one 7th, this one 8th, and this one 9th, and this one 10th. 10th is 1 dot x is equal to x. Okay, so when a certain set Rn, for example, Rn, later on we will change this set. Rn is a Euclidean space, n space. Then Rn or n space is called a vector space if elements of Rn together with addition and scalar multiplication basic operations, if that elements of that set Rn satisfy all these 10 properties, then we call it vector space. Okay.
So can you repeat?
I'm going to repeat it. Listen it carefully. A certain set V, for example, V could be any set, but here we are assuming that V is Rn. Okay. Later on, we'll change V to some other sets as well. Set of matrices, set of maybe polynomials, set of functions. It could be any set. If the elements of set, along with the two basic operations of addition and scalar multiplication, if the elements of that set satisfy all these properties, all these 10 properties, then we say that that set is a vector space. Okay. Here, what is that set? It is Rn. So if the elements of Rn, which are vectors, if those elements satisfy all these properties, then we say that Rn is a vector space. And we call it Euclidean vector space because it's a Euclidean n space. Okay, remember this. Later on, यहाँ पे
we
जी
say
जी
that okay, this particular set is part of a vector space or
No.
or Euclidean space or क्या मतलब could you please repeat this one?
set itself is a vector space.
Okay.
Okay.
Sir, no matter how small the values are, अगर एक set के अंदर सिर्फ 3 numbers है, तो that'll be a Euclidean space as well.
No, Euclidean space is an infinite space. Okay. How can be 3 vectors form a vector space?
3
The
vectors
first
can be
property,
part of it.
ठीक है, देखें, if you say that, for example, we have 3 vectors. We have 3 vectors, maybe x, y, z. Okay, this is a set, some set, maybe a set. Okay, and particular vectors, x is equal to maybe 1, 2, 3, and y is equal to maybe 0, -1, 8, and z is equal to 3, 5, 9. Can this set A be a vector space?
Sir said it can be part of a vector space, but it itself is not a vector space.
It's a subset of a vector space. It could be, but it cannot be a vector space. Why? First property क्या है? Closure property. Does that property satisfy for all these elements of A?
Yes.
Yes. Who is this?
No, sir. No. Don't.
पहली प्रॉपर्टी क्या है? कोई से 2 वेक्टर्स लें, उनका सम जो है वो उसी सेट के अंदर होना चाहिए. ये पहली
No, sir.
प्रॉपर्टी.
No.
Kindly mute your mics. पहली प्रॉपर्टी क्या है? X plus Y should belongs to A. तो ये A को बिलोंग करता है X plus Y? नहीं करता ना. तो पहली प्रॉपर्टी वैलिड होगी. ये तो बिल्कुल ही Now, tell me if you have Rn, then how many elements Rn can contain? Rn, n को हम particular कर लेते हैं. n को हम 2 कर लेते हैं, for example. n हमारे पास 2 है. Now, how many vectors this R square contains?
Infinite in 2 dimensions.
Nice.
This is actually the set R2 is. It's a 2-dimensional plane, XY plane. कितने एलिमेंट्स होते हैं उसमें टू XY प्लेन में? 2, 3, 10, 15? Infinite many. कितने पॉइंट्स होते हैं XY प्लेन में? So these are all points of XY plane. So how many points are there?
So 100,000 million.
The power is the dimension of the Cartesian product of R. ये तो पहले भी मैंने बताया था ना आपको. जी, hello, anyone who was asking the question?
So it was Fatma Khan.
All right, sir. Look, I think there's a confusion in how you phrased, the statement after writing the 10 laws. Could you please repeat that statement so I can be clear?
If any set, for example, this R2, if the elements of R2, elements means which are vectors, okay? The elements means these points. They are what? They are vectors. If the elements of R2 satisfy all those properties, 10 properties, then we say that R2 is a vector space.
So then can we also say that R2 is a Euclidean space?
This is a particular kind of a vector space, which we call Euclidean vector space. Other vector spaces, there exist other kind of vector spaces. We don't call them Euclidean vector spaces because this set is called a Euclidean set, Euclidean space. That is why we call them Euclidean vector space. Okay, just due to the name of this space.
सर आपने x y और z को क्या कहा था? ये सबसेट है वेक्टर स्पेस का.
ये वाला?
हाँ जी. नहीं, ये जो नीचे आपने इसके लिखा हुआ है, आपने क्या वर्ड यूज किया था? सबसेट.
x plus y belongs to A.
तो सर ये x plus y वेक्टर स्पेस नहीं है?
x plus y कौन सी? यार x plus y तो एलिमेंट्स हैं इसके. एलिमेंट्स हैं. वेक्टर स्पेस जो होती है ना, वो तो सेट होता है ना बेटा. ये वाला सेट हो सकता है वेक्टर स्पेस. ये वाला सेट हो सकता है वेक्टर स्पेस. अगर इस सेट के तमाम एलिमेंट्स वो प्रॉपर्टी सेटिस्फाई करें 10 की 10, तो फिर उस सेट को हम वेक्टर स्पेस कहेंगे, एलिमेंट्स को नहीं.
ठीक है सर.
अच्छा, ये वेक्टर स्पेस हम पढ़ क्यों रहे हैं? मतलब बोर सी चीज है. मैंने आपको पहले बताया था कि जो सॉल्यूशंस हैं लीनियर सिस्टम्स के, दे आर बेसिकली सेट्स. ठीक है. अगर आपके पास लीनियर सिस्टम में अननोन्स आपके पास 10 है, तो उसके जो सॉल्यूशंस होंगे वो R10 को बिलोंग करेंगे, क्योंकि वो वेक्टर्स होंगे विद 10 कंपोनेंट्स. ठीक है. अब उन सॉल्यूशंस की प्रॉपर्टीज को डिस्कस करना है हमने कि सॉल्यूशन किस टाइप का है, उसमें कोई इंफॉर्मेशन अगर हमने कोई वहां से निकालनी है, डिग आउट करनी है, तो हम कैसे करेंगे. फर्स्ट वी नीड टू डिस्कस व्हाट काइंड ऑफ सॉल्यूशंस आर दोस. ठीक है. व्हाट प्रॉपर्टीज दोस सॉल्यूशंस सेटिस्फाई, what kind of operations we can perform on two different solutions. What if we add two solutions, would the resulting vector be another solution? ये थोड़ा सा इसको imagine करें. What we are going to discuss, we are going to discuss the solutions of linear systems. अब solutions में क्या है? Vectors हैं. अब is it possible to add two vectors? Can we add three vectors? Can we multiply a solution with some other scalar? तो ये सारी possibilities जो हैं operations की, हम देख रहे हैं कि किस किस्म के operations हम उस पे कर सकते हैं. ठीक है. A set of certain operations which we can apply on the solutions of linear systems, we call them vector space. Nothing else. हमने इसको vector space क्यों कहा? ताकि whenever someone asks me that this is a vector space, I can immediately understand that any set of vectors which satisfy these 10 properties, that will be a vector space. Then now I am comfortable that the solutions of this linear system, I can apply these operations, this operation on the solutions of linear system, because they satisfy these laws, these operations, these properties. Okay? If someone says me that the set of solution vectors is not a vector space, then I have to check कि कौन से ऑपरेशंस में इन सॉल्यूशंस पे अप्लाई कर सकता हूं, कौन सी प्रॉपर्टीज को सेटिस्फाई करते हैं, कौन सी नहीं कर सकते. ठीक है. तो कैन आई मेक a new solution from three given solution? Can I multiply solutions with scalars and then I can add them? Is it possible? So in order to discuss the solutions of linear systems, what we need certain properties. And I put those 10 properties in a pack and I call it a vector space. Okay? If someone asks me that this set, whatever set is this, it could be solution of a linear system. This set is a vector space. Then I'm comfortable that I can apply certain operations on the elements of this set. This is basically the purpose of defining vector spaces. Okay? I hope you get it. Now, this set satisfies all those 10 properties. Now, R square. R square kya hai? It basically a kind of a set, similar kind of a set R square. It could be a solution of a 2x2 system that contains infinite many solutions. अब उस पे अगर वो solution set जो है वो R square है या कोई subset है R square का, then I have to check कि उस subset पे ये सारी की सारी properties जो है ना true हो रही हैं नहीं. ठीक है. So the purpose of defining all these things is basically initially in linear algebra is to discuss solution of linear systems. I hope you get it. Now, from these properties, I hope you can understand. Let me give some example which you can prove it.
सर I have a question.
जी जी बेटा.
सर आपने जो पहले A लिखा था जिसमें आपने XYZ लिखा था, if you want to make that a vector space, what conditions will we have to add?
The first thing is that no finite set is a vector space. No finite set is a vector space. A is a finite set, जो कि हमने पहले define किया था. It cannot be a vector space. Fixed number of elements. Fixed number of elements. Except one.
Sir,
if I define V to be a zero vector, it is a vector space. Zero is identity element means. It is a vector space. No other, let me think properly. No other finite set. Yes. Yes. No other finite set can be.
सर पे property 10 जो थी 1 मतलब एक्सरसाइज में 1 तो है ही नहीं.
क्या?
सर जो प्रॉपर्टी थी कि 1 into x जो
चले मुझे बताएं कोई एक 10 में से प्रॉपर्टी कोई एक बताएं जो इस सेट के लिए सेटिस्फाई नहीं होती. हाँ बोले आप पहले.
सर मैं कह रहा था जो प्रॉपर्टी 10 थी कि 1
10
multiply with that
1.0 क्या होता है? क्या होगा?
यही नहीं इसमें सेट में 0 0
0 होगा ना?
0.
तो यही प्रॉपर्टी थी तो प्रूफ हो रही है नहीं? 1 तो स्केलर है ना बेटा, स्केलर तो आप अलग से लेते हो ना।
अच्छा ठीक
स्केलर्स आप अलग से लेते
ठीक है
हो, स्केलर आप अलग से लेते हो, वो इस सेट में से नहीं लेते आप। Now tell me any one property which is not satisfied. Yes, you tell. Multiplicative inverse तो है ही नहीं उन 10 प्रॉपर्टीज में वेक्टर स्पेस में। एडिटिव इनवर्स है, जीरो का एडिटिव इनवर्स क्या होता है? जीरो, इट्स देयर। कम्यूटेटिव प्रॉपर्टी, 0 plus 0 is equal to 0 plus 0. एसोसिएटिव प्रॉपर्टी, 0 को 3 दफा ऐड कर दें, 0 ही आएगा। तो सारी की सारी प्रॉपर्टी, जी 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 जी,
हमने R square में भी तो डिफाइन किए थे एलिमेंट्स, देन हाउ इज दैट अ वेक्टर स्पेस?
आर स्क्वायर वाली?
हाँ, हमने इसमें फाइनाइट एलिमेंट्स लिखे थे, तो वो वेक्टर स्पेस कैसे है?
फाइनाइट? आर स्क्वायर में फाइनाइट कब लिखे थे हमने? आर स्क्वायर में लिखा था, आर स्क्वायर में तो इन्फिनिट में ही वेक्टर्स हैं। उसको हमने सेट नोटेशन फॉर्म में डिफाइन किया था। अगर आर क्यूब डिफाइन करते हो तो आर क्यूब को कैसे डिफाइन करोगे आप? इट कंटेन्स वेक्टर्स ऑफ दिस काइंड x1 x2 x3 such that x1 x2 x3 they are what? They are real numbers. So this is how you define R cube in notation form. But how many vectors it contains? Real numbers. You look at this set. This is doing x1, x2, x3 belongs to R. And R contains how many elements?
Infinite.
Infinite. Not infinite really, uncountable. Anything which you can count and it doesn't have any end, that is infinite. Uncountable, you cannot count the element of R. What is the number next to 1? Do you know? No. So we cannot count it. ठीक है? Infinite और uncountable में फर्क होता है. But usually people say it infinite. Okay?
तो अगर v equal to 1 ले लें,
हाँ?
अगर हम v equals to 1 ले लें, 1 बार,
हाँ,
तो सर
1
वो
बार
भी
ले लें,
वेक्टर स्पेस नहीं हो जाएगा?
प्रूव कर लें इसको। v is equal to 1 बार ले लें आप। 1 बार है क्या, पहले तो ये मुझे बताएं आप। 0 बार तो होता है ना कि 0 0 0 all the entries of that 0 vector is 0. 1 बार को हम क्या लें, सारी एंट्रीज 1?
जी,
चले ले लेते हैं 1 बार। आप इसको प्रूफ करेंगे ये वेक्टर स्पेस है ही नहीं। पहली प्रॉपर्टी प्रूफ करें। पहली प्रॉपर्टी क्या है? क्लोजर लॉ, अंडर एडिशन। 2 एलिमेंट्स लें कोई भी, उनको सम करें तो उसी सेट में होना चाहिए। ठीक है? अब इसमें 2 एलिमेंट्स हैं ही नहीं, इसी को 2 दफा ले लेते हैं। 1 plus 1, क्या आंसर आएगा?
2
2 है इधर?
नहीं,
तो वेक्टर स्पेस ना हो इधर। कोई एक प्रॉपर्टी वायलेट हो जाए, वे हम कहेंगे वेक्टर स्पेस नहीं है। ठीक है?
तो क्लोजर लॉ दोबारा समझा दें क्या है?
Clear law is that if you choose any 2 elements, x, maybe x and y belongs to R cube, this implies its sum is also in the same space, R cube. Does it hold for R cube? कोई से 2 एलिमेंट्स ले लें R cube के, कोई से 2 एलिमेंट्स ले लें R cube के, उनका सम करें, R cube में बिलोंग करेंगे? करेंगे या नहीं करेंगे? करेंगे ना, ऑब्वियसली। हाँ, कोई से भी ले लें। मसलन मैं ये लेता हूँ, x को मैंने ले लिया 1 0 11। जी 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 जी, हाँ, 2 एलिमेंट्स ले लिए।
I'm sorry, sir. लेकिन in order to make R cube a vector space, we will have to introduce a vector y and a vector z, right?
Yes. And vector? What one? Which one?
In order to make R3 a vector space, we will have to introduce vectors apart from vector x, like vector y and vector z. Or no?
In fact, basically, I call it x vector, which can have 1 0 11, y vector 5 minus 9 15. They both belongs to R cube. This is just notation of another vector in R cube. Okay. So you define vectors according to your need. It depends what property you are trying to prove. जी इसमें हम इन जनरल प्रूफ करेंगे इसको. हम क्या कहेंगे, हमने ये लिया ना, हमने प्रूव करना है कि ये इसको बिलोंग करता है. टू प्रूव x plus y belongs to R क्यूब. ठीक है. अब हमें पता है कि x क्या है. इन जनरल प्रूफ करेंगे हम इसको. कोई पर्टिकुलर एलिमेंट लेके नहीं करेंगे. अगर पर्टिकुलर एलिमेंट लेके शुरू किया तो सारी जिंदगी आपकी गुजर जाएगी और एलिमेंट्स खत्म नहीं होंगे. x1, x2, x3 and y is y1, y2, y3. ठीक. अब हम क्या करेंगे, x plus y लिखेंगे. It is what? x1 plus y1, x2 plus y2, x3 plus y3. This is what we obtained. Now, because x1, y1 belongs to R, this implies x1 plus y1 belongs to R. है ना? रियल नंबर्स के लिए तो दो रियल नंबर ऐड करें तो रियल नंबर होगा. ये भी आपका रियल नंबर है, ये भी आपका रियल नंबर है, ये भी आपका रियल नंबर है. ठीक है, रियल नंबर है ना. तो डेफिनेशन क्या है कि कोई भी वेक्टर जिसके कंपोनेंट्स रियल नंबर्स हैं वो किसको बिलोंग करेगा, आर क्यूब को. इट मींस, व्हाट डज इट मीन, इट बिलोंग्स टू आर क्यूब. ठीक है. सो दिस इज हाउ वी प्रूव इट. There are questions in the chat window. Let me see them. Sir, if we have to make a vector space, then what conditions will we have to add? What conditions or what elements? We cannot make A to be a vector space because it contains finite many elements. ठीक है. कोई भी मुझे नहीं याद पड़ता कि कोई finite elements के साथ vector space हो. नहीं, सिर्फ सिवाय इसके जीरो वाली. देख
सर, एक हम ऐसा सेट फाइंड कर सकते हैं जिसके एलिमेंट्स ही डिफरेंट यूक्लिडियन स्पेसेस हो.
No. You cannot choose elements from the different Euclidean spaces. You cannot have x from R2 and y from R3. You cannot add a vector with 2 components to a vector with 3 components. That is not possible. Okay? You have to stick with the same dimensional space. Now, let me change this space. What will happen? Now I'm going to define let V is M2 cross 2, where M2 cross 2 is a set of all 2 cross 2 matrices. Okay, set of all 2 cross 2 matrices. Okay. It means, how do we define it? M के एलिमेंट्स किस टाइप के होंगे? ये मैट्रिसेस को हम कैपिटल लेटर से डिनोट करते हैं. कोई भी लेटर ले लें, इन जनरल ए कर ले लें, या आप ए से डिफाइन ना करें इसको, कुछ भी ले लें, एनीथिंग. सो यू से दैट दिस इज A1, A2, A3, A4, such that A1, A2, A3, A4 they are real numbers. ठीक. Now, मैट्रिक्स एडिशन और मैट्रिक्स स्केलर मल्टीप्लिकेशन आपको पता है कैसे होती है? यू नो इट. ठीक है. दैट इज बेसिकली अ स्टैंडर्ड मैट्रिक्स एडिशन एंड स्टैंडर्ड मैट्रिक्स स्केलर मल्टीप्लिकेशन. ठीक है. दो मैट्रिक्स को हम कैसे ऐड करते हैं, यू नो इट. ठीक. प्रूव दैट M22 is a vector space. how
shouldn't it be
do we?
V?
Yes.
Shouldn't V be a vector space?
Yes,
Not
V
M2?
is 2 cross 2 basically. V is what? Now we are changing V to M2, 2 cross 2. Okay. V is a general name for a vector space because vector space starts with the letter V. Okay. Now the properties, अच्छा, जो addition and scalar multiplication कैसे define होंगी? Standard होंगी. With prove that this is a vector space with standard addition and scalar multiplication. Okay. Now, what is the first property? We need to prove what? Closure property under addition. Okay. Closure property क्या होती है? Basically you should know the nature of the properties and how can we prove it. Okay. Now, in order to prove the closure property, first under addition, what we need any two elements. Okay. हम क्या करते हैं? Let A B belongs to M 2 cross 2. A और B क्या है? दो मैट्रिसेस हैं 2 cross 2 ऑर्डर। वहां पे X वेक्टर या Y वेक्टर नहीं लिखेंगे हम। Nature of the set have been changed. Now the elements of set which is under consideration is matrices. तो matrices को कैसे डिनोट करते हैं हम? A B से। अब हम X वेक्टर Y वेक्टर नहीं लिखेंगे, हम क्या लेंगे? दो एलिमेंट्स लेंगे उस सेट के जिसको हम वेक्टर स्पेस प्रूव करना जा रहे हैं। ठीक है, ये लेंगे। हमने प्रूव क्या करना है? टू प्रूव A plus B belongs to M22. ओके, इसको प्रूव करने के लिए हम क्या करेंगे? क्योंकि A B जो है M2 क्रॉस 2 को बिलोंग करता है, देन A को हम कैसे लिख सकते हैं? A को हम लिख सकते हैं कोई भी जनरल मैट्रिक्स 2 क्रॉस 2, A1 A2 A3 A4। ठीक है, और B को हम कैसे लिख सकते हैं? B1 B2 B3 B4। मैट्रिक्स हम नहीं ले सकते, हमने एब्स्ट्रैक्ट काइंड ऑफ नोटेशन यूज करनी है which will work for every element, every two elements। ठीक है, for any two elements हमने प्रूफ करनी है ना। तो यहां पे let ना करें, for all AB belongs to this means you can choose any AB, any particular value of AB, 1 0 0 1 or 2 10 minus 12 50 anything। Now अब हमने कंसीडर क्या करना है? कंसीडर करना है, हमने प्रूफ करना है बेसिकली कि इनका सम जो है M22 को बिलोंग करता है अंडर यूजुअल एडिशन एंड मल्टीप्लिकेशन। तो A प्लस B क्या होगा? दो अगर मैट्रिसेस को हमने ऐड करना है तो क्या होना चाहिए? वो A1 प्लस B1 A2 प्लस B2 A3 प्लस B3 A4 प्लस B4 which is another 2 cross 2 matrix। है ना 2 cross 2 matrix है, तो it belongs to M2 because A plus B is a 2 cross 2 matrix। If it is 2 cross 2 matrix, then it should belongs to M2 cross 2। You have to give the reason here why we are saying that A plus B belongs to this, A plus B equal to this, why this matrix belongs to this set। ठीक है, अब मैं यहां पे एक और कंडीशन लगा देता हूं कि M2 cross 2 set of all 2 cross 2 matrices with determinant equal to 0। वो मैट्रिसेस हैं इसमें जिनका डिटरमिनेंट 0 है। ठीक है, अब हमने अगर प्रूफ करना है कि A और B M2 cross 2 को बिलोंग करता है तो हमने क्या करना है? सॉरी, A प्लस बी अगर प्रूफ करना है, पहले हम लिखेंगे कि A प्लस बी क्या है, ये है। अभी हम ये नहीं कह सकते कि ये M2 क्रॉस 2 को बिलोंग करता है। अभी हमने हाफ ऑफ द प्रॉपर्टी प्रूफ की है कि A अगर 2 क्रॉस 2 मैट्रिक्स है तो दो मैट्रिक्स का सम जो है वो 2 क्रॉस 2 मैट्रिक्स है। A तब यहां पे बिलोंग करेगा जब A का डिटर्मिनेंट 0 होगा यहां पे, एंड डिटर्मिनेंट ऑफ A is 0। Now this set has been changed। Up, if we want to prove that A plus B belongs to that set, we also have to prove that determinant of A plus B is 0. Then the sum of two matrices A and B, it will go to that set. Okay? Now, let's say that यहाँ पे हम कहते हैं कि determinant of A plus B को consider करें आप. Determinant of A plus B. इसको हमने proof करना है कि 0. Where we know that determinant of A is 0 and यहाँ पे क्या है? Determinant of B is again 0. Can we, with this information that determinant of A is 0 and determinant of B is 0, can we prove that determinant of A plus B is 0? कैसे prove कर सकते हैं? Now you are using this thing that determinant of A plus B is equal to determinant of A plus determinant of B, and this is 0 plus 0 is equal to 0. ये यूज कर रहे हो आप? हाँ जी.
सर ये तो गलत है, ये तो हो नहीं सकता.
और किसने प्रूफ किया ऐसे?
सर इसे मल्टीप्लिकेशन के लिए होता है, एडिशन के लिए नहीं है ये.
ये प्रॉपर्टी होल्ड नहीं करती. ये प्रोडक्ट के लिए ट्रू है, सम के लिए नहीं है. मैंने आपको पहले बताया. ठीक है. So we cannot prove it that this is equal to 0. We cannot prove it. What does it mean? A plus B does not belongs to M2 cross 2 in general. So the clear property is not satisfied here. We stop here and say that the given set is not a vector space. ठीक है? We cannot prove it. दो ऐसे आप काउंटर एग्जाम्पल दे सकते हैं. यहाँ पे काउंटर एग्जाम्पल क्या दे सकते हैं? फॉर एग्जाम्पल आई एम गोना चूज two determinants, two matrices A and B. Determinants are 0. ठीक है. For example, यहाँ पे मैं ले रहा हूँ 2 and maybe 3 and 2 and 2. यहाँ पे आप 3 ले लें, यहाँ पे भी 2 ले लें. ठीक है. या कोई और नंबर ले लें. You think about it. कि दो कोई ऐसे मैट्रिसेस डिफाइन करें, इसका डिटरमिनेंट तो 0 होगा, लेकिन यहाँ पे 1 0 maybe 0 0. ठीक है.
सर ये प्रूफ्स क्वेश्चन में आएंगे पेपर में? सॉरी.
जी जी जी. ये ए और बी दो मैट्रिसेस हैं, इन दोनों के डिटरमिनेंट 0 है. ये उस सेट को बिलोंग करते हैं. ठीक है. इन दोनों का सम लेंगे तो उसका डिटरमिनेंट 0 है?
नहीं.
नहीं है ना. It means that this set elements of this set, they do not satisfy a clear property. So if at least one of the properties of the vector space are not true, then we say that it's not a vector space.
जी सर, सबसे पहले जो आपने मैट्रिक्स डिफाइन की थी जिसमें बगैर डिटरमिनेंट वाली, उसमें आपने क्लोजर लॉ तो प्रूव कर दिया था, लेकिन जो फिफ्थ लॉ है जिसमें इनवर्स ऑफ ईच एलिमेंट शुड एग्जिस्ट, तो अगर उस सिचुएशन में कोई आपकी ए या बी कोई मैट्रिक्स का अगर वो 0 आ जाता है डिटरमिनेंट, तो फिर तो इनवर्स लॉ तो प्रूव नहीं होगी.
वो एडिटिव इनवर्स है बेटा. मल्टीप्लिकेटिव, यू आर थिंकिंग अबाउट मल्टीप्लिकेटिव इनवर्स. एडिटिव इनवर्स किसी भी मैट्रिक्स का क्या होगा? उसकी मैट्रिक्स की एंट्रीज को उसका साइन चेंज कर दें. ठीक है. Additive inverse is a different thing and multiplicative inverse is a different thing. I hope you get it.
Okay, sir.
Now, in order to prove any set of vector space, you have to look at the nature of the elements of that set and the conditions on elements of that set. Okay. You have to prove all those conditions. Then you have to look at the laws and certain properties in order to prove that set of vector space. You start with the first property. Okay, यहाँ पे देखिए अगर तो ये condition ना होती determinant of a is equal to 0 वाली, ठीक है, तो फिर तो ये vector space बन जाता क्योंकि M2 cross 2 is a vector space. You can prove all those properties, but you have to think the nature of the set, nature of the elements. कोई भी यहाँ पे एलिमेंट लेंगे तब उस सेट को बिलोंग करेगा जब इसका डिटरमिनेंट 0 होगा। कोई भी ऐसा एलिमेंट, ऐसा मैट्रिक्स 2x2 जिसका डिटरमिनेंट 0 नहीं है, वो इस सेट में नहीं होगा। अब आपने अगर दो एलिमेंट्स लिए जिनका डिटरमिनेंट 0 है, इसका आपने प्रूफ करना है कि सम भी इस सेट को बिलोंग करता है, तो देन यू हैव टू प्रूव दैट the determinant of sum of these two matrices is 0, which is not basically true. हमने एक काउंटर एग्जांपल दिया है यहाँ पे। So this property cannot be proved. That is not a vector space. ठीक है, हम एक दो एग्जांपल्स करेंगे लेक्चर में वेक्टर स्पेसेस की for different cases. Then we'll move further. If you have any question, you can ask me. If you don't have any question, I'm going to.
सर तो एक वेक्टर स्पेस को मतलब हमें प्रूव करने, जैसे ये 2x2 का मैट्रिक्स है, तो हमें 10 की 10 प्रॉपर्टीज प्रूव करनी पड़ेंगी।
जी, यस।
अच्छा।